Welcome everyone to another PowerBox core transmitter video. In this particular video we'll be covering binding receivers to my PowerBox core radio. Just pictured to the right of my screen is a PBR-9D, which is primarily a 9-channel PWM receiver, which can also be configured as a 10-channel output receiver. It features two full-time independent receiver circuits in the one housing. So it's actually two receivers in the one box. The system treats it as one unit, even though there's two receivers in it. So therefore you can receive telemetry from both receivers. So both receivers feature full-time independent telemetry, and parameters such as RSSI, link quality indication, voltage and all that sort of stuff is can be displayed on the screen. Okay. At the moment it's not bound to my core radio. So let's switch it on and see what happens. So you notice there's a fast flashing green LED on the front panel, and that after about 10 seconds that'll switch to a red flashing indication. The bind process can only occur while it's flashing green, and that's normally enabled by switching power onto the unit. So let's bind it to my radio. So over here on the core screen, I'm just currently in the main menu. I've got a couple of widgets set up which I was playing around with, but let's navigate to the receiver screen where we can do our binding. We'll go into that, and here we are in the main receiver screen, and at the moment you'll notice there's an A, B, C, D column. There's no receivers bound to this particular model, and the core can allow up to 4 receivers to be bound to it. So in theory we could bind 4 of these 9Ds to my core. Now if you did that, like I said, don't forget there's actually 2 receivers inside this unit. If you bound 4 of them, it would provide the user with 8 receiver circuits for their aircraft. So if you had a really large aircraft, you might want to consider binding up to 4 individual receivers. And like I said, that'll provide you with 8 full-time RF paths as far as your radio system's concerned. Again, plenty of redundancy there. Okay, now let's bind this receiver to my core. So switch it on, we get the fast flashing green LED. We can bind it to any one of these slots. Let's bind it over here on A. Just hit the bind button, just takes a few seconds. And you'll notice the green LED that was originally flashing has now gone to a solid on condition. So whenever this receiver's receiving a valid transmit signal from the transmitter, the green light should be solid green. And you'll also notice there's a little there's a little picture of the PBR-9D receiver in slot A. And it's as simple as that. It's pretty easy. Now, early this year, PowerBox designed and developed a satellite receiver option. So they manufactured a little receiver called a PBR-26S. So this little receiver is actually quite thin. It's only about 4 millimeters thick. There's a servo connector on the left-hand side and a single antenna. And basically, it's just a single receiver, but you can actually hook it up to the 9D as an extra receiver to form a satellite function. Not too dissimilar to, say, Spectrum and some other manufacturers. And it basically provides you with the ability of mounting, because it's so small and thin, you can mount this receiver, for instance, in a vertical tail fin, or even in a horizontal wing if you wanted to. But the tail fin is probably a good example where you can mount this receiver inside the tail fin and then just run a servo lead all the way back to this particular receiver. Or if you're running a PowerBox, you can run it to the PowerBox. The bus that it uses is the fast track bus. So those existing PowerBox users should be familiar with the fast track data option as far as a bus is concerned, as well as the P2 bus, which is a telemetry bus. So just remember that P2 bus is always for telemetry. So all your sensors and whatever will plug into this bus. However, the fast track bus is a separate bus. It's a high speed bus and that allows you to hook features such as gyros or GPSs, or in this case a satellite receiver. Now this particular receiver can also be used as a standalone receiver. So using it as a standalone receiver, you could feed out, say from here, you could feed out, say, S-Bus. You can configure this port as an S-Bus output, and you could feed that into, say, a flight controller, like for a flybarless controller for a heli. And basically this receiver will just function as a normal receiver, just outputting an S-Bus signal. But just always remember it's just a single receiver, so it doesn't have any receive diversity functions. So in this example, we're going to bind it to my core and use it as a satellite receiver, a full-time satellite receiver. So I'll just grab this particular PBR26XS. I'll turn off power to the 9D, and I'm just connecting the little servo cable that's already plugged into the fast track port of the 9D. I've got a little bit of blue tack on the back of the 26S just to hold it in place while we talk about it. So this servo cable just plugs into the fast track port on the 9D. So remember, we're using the fast track connection. So this needs to be configured to have its output port set to fast track mode. Anyway, we've now physically connected to it, and let's apply power. So, got power applied. You'll notice the 9D's gone into its normal mode, indicating that it's bound. However, we have a fast flashing blue LED on the 26S, and now it's gone to red. So similar to the 9D, when you have a fast flashing blue indication, it indicates the 26S is ready for binding. So let's turn the power off again so I can put it back into its normal binding mode, and then we'll bind it to my my core radio over here. Oops. Let's go back into the receiver menu. Switch the power back on. Got the fast flashing blue. Let's hit the bind button. Give it a few seconds. And bingo, it's now bound to my core. So at the moment, you'll see the little picture of the 26SS on the core screen, indicating that's bound to slot B. So now, that's it. It's now being used as a satellite receiver. The actual connection, don't forget, is fast track, so this must be configured for fast track output. And now basically, if the 9D for whatever reason loses its two receivers, or basically its receivers, the two antennas become blocked from an RF perspective, as long as the satellite receiver can still see the transmitter signal, your whole aircraft will still be functioning A-OK. Okay, that'll do for this video. Thank you.